Today we're going to discuss one of Zeno's most famous paradoxes, the Achilles and the tortoise paradox. For those of you who don't know, Zeno of Elea was a well-known Greek philosopher, and he came up with a list of paradoxes, one of which we're going to dive into in this presentation. The reason why this paradox is called Achilles and the tortoise is because of the story that is told to explain it. Suppose that there is a race, in which the participants are Achilles and a tortoise. Before the race begins, the tortoise is given an 100-meter head start. Once the tortoise has reached these 100 meters, Achilles begins running to catch the tortoise. Achilles has now reached the 100-meter point where the tortoise was initially. Nevertheless, in that time, the tortoise has advanced another 10 meters. Achilles keeps on running, and once again catches up to the 10-meter point where the tortoise was previously. Yet again, during that time, the tortoise has advanced 1 more meter. This goes on again and again. Every time that Achilles reaches the point where the tortoise was previously, the tortoise has moved further on, even though these distances become smaller every time. In consequence, this leads to the question, does Achilles ever catch the tortoise?
Let's look at a similar example, one that we came up with, that poses the same paradox, but from a different perspective. Suppose there is a climbing wall, and this wall is 8 meters tall. Pedro, a professional climber, wants to climb this wall. In order for the climber to reach the top of this wall, he must climb it, obviously. But this action of climbing the wall in order to reach the top can be expressed in other words, as reducing the distance there is between the climber and the top of the wall. One way in which this distance can be reduced is by halves. For instance, Pedro will first climb 4 meters, which is half of the height of the wall. Then, he will climb 2 meters, which is half of what he previously climbed. He will then climb 1 meter, with 0.5, 0.25, and so on. As in the case of Achilles and the tortoise, we pose the question, will the climber ever reach the top of the wall?
We can approach this paradox from a mathematical point of view. Let's think again of the climbing wall example. The height of the wall is 8 meters, which means that Pedro has to climb 8 meters in order to reach the top. As mentioned, he has this distance, giving us 4 meters. He has this distance again, giving us 2, then 1, then half of a meter, then a quarter of a meter, then an eighth, a 16th, a 32, and a 64, and so on, having the distance infinitely. Let's give this sum a value, in this case s, for sum. Now, we will multiply this whole initial sum by 1/2. As you can see, s becomes half s, as it has been multiplied by half. Now we will multiply each individual term by half, starting with the term 4. 4 times a half is 2. Continuing this methodology, 2 times a half is 1, 1 times a half is a half times a half is a quarter, etc. The next step is to subtract these two sums, starting with the left side. S minus a half s gives us another half s. On the other side of the equation, we can see that all of the terms cancel out except for 4, since it is the initial half. 4 is all that we are left with now. Our equation is half s equals 4. This results in the value of s being 8, since 2 times 4 is 8, and as you know, 8 meters is the height of the wall. What this shows us is that the climber would climb 8 meters, meaning he would reach the top, even though this is an infinite process.
These types of sums are known as well-behaved sums, which can be defined as a sum that gets closer and closer to a value, which, on infinity, is equal to the value exactly, as was illustrated with the wall example. Let's dive deeper into well-behaved sums, as they are an important part of this paradox. As you know, we have an initial sum. Now, let's break it down. So, let's take one of the values of the sum and call it x subscript n. And we divide this value by the number that came before it, x subscript n minus 1. In order to avoid this value being negative, we will use the absolute value for this division. Now, if these numbers are going towards a value, let's call it y, as this x gets bigger, that is, moving towards infinity, and if that value is less than 1, then this is a well-behaved sum.
The reason why this demonstrates that this is a well-behaved sum is because if you take any term and divide it by the previous one, you will always get 1/2, which is a value less than 1. Thus, this sum is well-behaved. In conclusion, after analyzing Zeno's paradox of Achilles and the tortoise and the climbing wall example through a mathematical point of view, Even though it sounds like we can complete an infinite process does not have a final step or last step. So, how can something without a last step be completed? This is why we call this a paradox.